Good morning, everyone, and welcome to another STEM Inspiration Week session. And today, Friday, is our Maths Day, and we're really lucky to have some very interesting speakers today with us. So just to kick off, I wanted to let you know this session is being recorded, and we've got your cameras and mics switched off, and if you can keep it that way, that just minimises the background noise. What you will need to do for this session, though, is we need a bit of interaction with you. So we are going to be asking you to do something. So hopefully you're all set up and your teacher should have let you know a little bit about the session.
You're talking to yourself.
So if you can nominate somebody from your class, if you haven't all got individual access to a keyboard, nominate somebody from your class to join the chat function. Could be a teacher, that's fine. If teachers can let us know which school you're from and how many students you've got with you, that'd be really helpful for us. That just shows us that you've got the chat function working. So if you can join now and just type in your school name and how many students, which year group you're from, that would be really, really helpful. And also you'll see at the bottom, if you sort of move your cursor down to the bottom, there's some reactions. You can, on the right hand side at the bottom, you can do a reaction. That also helps us let us know that you're actually with us and you're playing along with what we're doing. So if you can all try and use, yep, thank you. We've got Chalk Hills, yep, thank you very much. Yeah, if you can add your school name and your number of students, that'd be really fantastic. And then I'm going to now introduce you to our speaker, who is David Sheffield. David is a toxicology modeler from Unilever, so very famous company. And I think he's going to sort of give you some very interesting, challenge you in some interesting ways today. Thank you. Take over, David.
Good morning. Let me just get the presentation up. So so I'm going to be looking at this subject: are greedy people more successful? So that's so we're going to look at something called risk and how that affects us in our day-to-day work, and I'll tell you a little bit about my job as well. So first I'm going to tell you a little bit about myself, then I'm going to introduce this idea of risk. Is risk a good or bad thing? Then we're going to play a game, very exciting game that you're all going to take part in. And it'd be useful if you had a pen and paper handy to jot down scores. It could be a flip chart or a whiteboard, or it could just be a notepad next to your computer. But you'll need to keep track of your score. And if there's time at the end, there'll be time for some feedback and questions. And we can use the chat function to write down any questions. In fact, you can type in any questions as we go along. It might be about my job or about the presentation, and then if there's time at the end, we'll go through those. So start off by telling you a little bit about myself. So this is me. I am a statistician, and I've been doing that for 15 years. And what a statistician is, it's someone who likes to apply maths and mathematical techniques to the real world. So it's kind of maths but interesting, and it's making sense, looking at problem solving. I got into it because I love problem solving and puzzles. I'm quite a curious person. I want to see what's going on. I remember when I was younger, going on long car journeys, and I'd be keeping tallies of what colour cars were on the roads. And the answer is grey, by the way, was the most popular. And seeing which ones there were, which were around. It's that kind of idea of what's happening in the world, what's interesting, and how can we apply maths to test things and see what's going on. To do my job now, I studied at university for 4 years. So I work for a company called Unilever. You may not have heard of Unilever, but you've probably heard of some of our brands that we own, and there's some of them on the screen there. I expect, and I kind of hope, that you've got some of those in your house, or ones that you even buy. And we make things that we call consumer goods, things that get used up fairly quickly. So Unilever, somewhere in the world, on any day, 2.5 billion people use Unilever products, and you'll find us in over 190 countries, and we employ more than 150,000 people. So where does my job fit into that? Well, I work for a department called the Safety and Environmental Assurance Centre. So our role is to check that the products and the methods of making those products and even the disposal of those products are safe for the people who use them, our consumers. They're safe for the environment, and they are the manufacturing process is safe as well. So to give you a quick example, here's an apple. Now, apples are healthy. Everyone knows that apples are good for you, but they contain vitamins, fiber, something called polyphenols, and they're good for you because they help to lower your risk of heart disease. They help with weight loss, and they improve your gut health. You get a lower risk of diabetes and cancer. But did you also know that apples contain cyanide, and cyanide is a poison? So why do we still eat apples? Well, actually, if we look into the details of cyanide, they're contained in the pips, and cyanide is only released when the pips get ground down. So if you were to chew on a pip, you'd be releasing cyanide. But you would need to eat over 100 pips for it to cause any harm. So, actually, we can say that the risk of harm from eating an apple is very low. In fact, it's very tiny compared to all that benefit of eating an apple. So applying this idea to what we do in my department is, for instance, if you have some bolognese sauce, now the sauce it might be made in a factory where they also make things containing nuts, and we know that people can be allergic to nuts. So some of that nuts might get into the bolognese sauce. So we want to know, what is the risk that someone who is allergic will get ill from eating the sauce? Another thing to think about is a washing powder, and we put a lot of chemicals in the washing powder, and we need those chemicals to be quite strong to get rid of stains and wash your clothes properly. But if you're exposed to these chemicals for a long time, then it can start to cause skin irritation. So we want to know, what is the risk that a factory worker is affected by these chemicals? And the third picture is of some toothpaste. So what do you do when you've brushed your teeth? You spit out the toothpaste into the sink, and then you wash it down the plug hole. But then what happens to those chemicals that are in that toothpaste? Well, they go into the sewage system, and then they go through, they're cleaned, and the wastewater is pumped out into rivers. So what about the chemicals we put in toothpaste? How do they affect wildlife? So what is the risk to wildlife living in the rivers from the chemicals we put in the toothpaste? So these are all different examples of the sort of things that I do in my job at Unilever. So to think a bit more about that idea of risk, we're going to play a game. We're going to do an activity. Now, you can do this as a team or as an individual. I suggest if you're in a classroom with a group of people and you're watching one screen, then you work as a team. Or if you're just on your own, then you work as an individual. But each team or individual will need to keep score of as we go along. So let me explain how the game is going to work. So I have with me a dice. It's a fair dice as far as I know, and I'm going to roll it twice. So let's do an example. Let's roll it a 2, and I'll roll it again into the box, hopefully. 2 and a 3, so we're on to 5. So everybody has scored 5 points. Now the next part of it is you have to decide. You get a decision to make. Are you going to bank those 5 points? And so your round 1 score will be 5. Or are you going to have a risk? And the risk is that the dice will be rolled again, but this time, if we roll a 6, then you wipe out and your round score will be 0. However, if a number other than 6 is rolled, then we're going to add that to our score. So we're already on 5. If you risk, we roll it again. It's rolled a 2. So that means we're on 7. So now, are you going to risk or bank? Are you going to bank that 7 points, or are you going to risk another roll? And we're going to keep rolling until either everyone has banked their score or a 6 is rolled, and that means that people wipe out. So what would be helpful for me is if you are risking, so you're going to risk another roll, that you shove probably a thumbs up picture from the reactions onto your screen, and then I can see that people want to roll again. And I'll give you enough time to make that decision. And what I'll do is, if I don't see any thumbs up, I'll probably roll again anyway, just to make sure I haven't missed anyone. And then we're going to play this over again. And once you've banked it or a 6 has been rolled, we'll then start another round, and we'll play several rounds, probably about 5 rounds, but we're going to do it for 15 minutes. And when we reach 15 minutes, we're going to stop, total up all your scores from all your rounds and see who's got the highest score. So it's a bit of a competition, and we'll see who's got the highest score at the end. So I'm going to stop sharing my screen, and so I can see all your screens and see if your reactions. So here we go, first round. I'll check the time is okay. Right, so I know when 15 minutes are up. So roll number 1, I'll move the camera down so you can see, it's a 5. And roll number 2 is a 6. So that's a great start. We're on 11 as your starter roll. So I'll give you about 15 seconds to decide if you want to risk another roll or if you want to bank those 11 points. So if you're going to risk, then I want to see a thumbs up on your screen. If you're banking, then you don't need to do anything. You can just write down 11. Okay, just a few more seconds to go. And I can see there's a couple of people who are going to risk. So if you're risking, if this is a 6, you wipe out. Otherwise, you can get to increase your score. So it is a 4. So we were on 11, now we're up to 15. So 15 if you risked, 11 if you decided to bank. So now, I'll give you another 15 seconds to decide, are you going to risk? We're on 15. So I can see a couple of thumbs up. Obviously, if you banked, you can't then risk. So I can see two thumbs up. So we're going to roll again. Last chance for anyone to risk. Okay, here we go. I missed the box, but it's a 1. So that takes us from 15. That's 16 points. So are we going to risk or bank? If you're risking, thumbs up. We're up to 16. So I'll give it a roll. Here we go. It's a 3. What were we on? 15, 16. 11 plus 4 is 15, 16, 17, 18, 19. Okay, so if you were risking, you're on 19 points. Okay, I can see a couple of people want to risk, so we'll keep going. Remember, if 6 is rolled, you get 0. It's a 1. So we're up to 20. Okay, so if you're risking, put your thumbs up on the screen. So there are some more people risking. We're on to 20. Okay, so we roll, and it's a 6. So anyone who was risking has scored 0 for this round. If you've already banked, write down that score for round 1, and we're going to move on to round 2 in a second. Okay, here we go. First two rolls. First number is a 6. So again, we're starting high. That's not a wipeout because it's the 2 free rolls. 6 and 1, that's 7. So we're on to 7. Are you going to risk rolling again and put a thumbs up? Or are you going to bank those 7 points? So I've got 2 thumbs up, I can see. I'll just give you a few more seconds. Okay, so if you are risking, here's your next roll. So we're on 7. It's a 3. So that's 10. We're on to 10. Okay. So I'll give you a few more seconds to decide if you're going to bank the 10 points or if we're going to risk another roll. Okay, here we go. It's a 5. So that takes us up to 15. Okay, so are you going to bank the 15 or are we going to risk another roll? I'll give you a couple more seconds. So we're on 15. Okay, here we go. It's a 6. So if you risked, you've wiped out to 0 and you score 0 for this round. Hopefully you would have banked before that roll and scored 15, but let's see what happens. Okay, everyone's back in again for round 3. So 2 free rolls. We got a 5 to start. That's a good number. And a 6. So we're on 11. So we're starting with 11 points. Are we going to risk or bank? Okay. So I can see it. 1, 2, 3. You can see 3 thumbs up at least. I may have missed some. So I'll give you a couple more seconds. Here we go. It's a 1. It takes us on to 12 points. So not much increase in the score. So may mean you want to risk again. I can see 1 person deciding to risk there. 2, 3, 4, 5. Okay, so a couple more seconds to decide. It's a 3. We're back up to that 15 points again. So I'll give you a few more seconds again. You know what to do. If you want to risk, give us a thumbs up. We've got a couple of people deciding to risk. So we'll roll again. For those of you who've banked, you'll probably hope this is a 6. If it's not, it's a 4. So now we are on to 19 points. Okay, so again, a few more seconds to decide. Are you going to risk? I can't see anybody risking, but I will roll the dice anyway, just in case. So you can have 19 points if you've decided to bank, but if not, it's a 3, which takes us on to 22. Okay, is there anybody risking? I can't see anybody risking. So I think we might stop there for that round. So we're stopping at 22. Okay, now up to round 4. Here we go. So we start with a 3 and a 4. So we're on 7 points to start us. So are you going to keep those 7 points or are you going to risk? Thumbs up for a risk. I can see a few people are definitely going to risk their 7 points for some more. Okay, last few seconds to decide. That's a 5, so 5 plus 7 takes us up to 12. Okay, I'll give you a few more seconds to decide whether you want to risk or bank. Okay, so there's a few people deciding to risk. So here we go. We were on 15, that's 12, sorry, that's 3. We're now up to 15. Okay, so risk or bank. A few more seconds. I've got 2, 3, 4 thumbs up, 5. A few people getting a little bit braver here. See what we're going to do. We're on 15. So 1. So that takes us up to 16 points. Okay, lots of people. I can see 4, 5 people. Anybody else wanting to risk those 16 points? Okay, here we go. It's a 1. So that is 17. Okay, last few seconds to decide to risk or bank. You can see 1, 2, risk. So here we go. We're on 17. Roll the dice, it's a 3. So we're up to 20. Okay. Some people being very brave here. Are we going to risk those 20 points? So a few more seconds to decide what to do. And we've scored 5. So we're up to 25. You may have noticed we've had more than 6 throws, so a 6 should have come up but in probability by now. So definitely getting into the very risky part of this, but we're on 25. Anybody risking? I think I've seen a couple of thumbs up. So a few more seconds. So here we go. It's a 1. So now that takes us up to 26. And we've definitely got one person risking, so I'm going to keep going on this one. We're on 26. Okay. So last few seconds to decide. I think we might have time for one more round after this one. It's a 3. So that's 29 points. Okay. Again, I see more thumbs up. It could be a 6 any moment now, but it might not be, of course. 29, here we go. It's a 6. So if you were still risking, then you score 0. Otherwise, write down your score for the round. And we've definitely got time for just one more round. So here it is, everybody's back in. It's a 6 to start us, it's a good starter number. And a 3, so we're starting on 9 points. Right. Risk or bank. Everyone's back in. I can see a few people risking. We're on 9 points. Okay. Last few seconds to decide. Thumbs up if you're risking. And it's jumped out the box, but it's a 5. A good number to have stayed in for. So we're up to 14 points. Okay. So a few more seconds to decide between yourself whether to risk. Some people are risking. So here we go. I'll do that one again because it's jumped off the box. So 1. So we're up to 15. If you're still in, 15. If you want to bank 15, you can, or you can risk another roll. If you're risking, put your thumbs up. Give you a few more seconds to decide. Okay, here we go. 4. So that takes us up to 19 points. Okay, so we're on 19. Who's going to risk 19 points? A couple of people risking it. So a few more seconds. Maybe you've wiped out a few times, you need to catch up on some score. Maybe you've got some good scores in the bank and you want to keep them. Let's see, here we go. It's a 3. Moves us on to 22. Okay, so anybody risking the 22? I can see one thumb, 2, lots of people risking, living on the edge. Here we go, a few more seconds to decide. And it's a 6. So if you're risking, then you have wiped out and scored 0 for that round. Okay, so what I need you now to do is to add up your scores from all the rounds, and your total score will be the sum of all those scores. And then if you could write your final score in the chat, and one of the STEM team is going to monitor that, and at the end we'll see who's got the highest score and who's won. And unfortunately there's no prizes, just the joy of winning and the bragging rights that you won the game. So let's go back to presentation. So I wonder how you got on with that. There we go. I wonder what drove your decision, whether you wanted to risk or bank. And I wonder whether it was the number you decided on, a set number of roles that you were going to you were going to stay in for, or maybe you decided on a certain score you wanted to get to, and once you got to a good score that you would then bank, or maybe you were going on gut feeling and kind of going, I feel this is not going to be a 6, so I'm going to stay in, or I feel the next number is going to be a 6, I'm going to bank. Maybe you were just banking at whatever value a low value because you really didn't want to wipe out, or perhaps you were looking to see who else was risking, and if most other people were risking, you thought, well, they seem to know what they're talking about, I'm going to go with what other people are doing. So what we can do, because a dice is pretty straightforward mathematically, we know that each number's got a 1 in 6 chance of occurring, is we can actually use some maths to see what would be the best strategy. So the first strategy is, what if we decided on a certain number of roles that we were going to stay in for? So let's think about this. We know we get 2 starter roles, so we could stop after no extra roles. So we know that the first role, it could be anything between 1 and 6, and also the second role could be any number between 1 and 6. That gives us 36 possible combinations, and there's the numbers. And we know that 7's got 6 different ways of being made. So 7 is our most popular number that we're going to get, but we could have 2 1s and end up with a number as low as 2, or we could end up with a number as high as 12. So it's quite a distribution of values. So there's our distribution, and it shows us that we could get any of those, but we want to have some statistics, some value that we can use to see which is the best strategy. So you may have come across the mean. It's all the numbers added together divided by the number of values that we had. So if we add all these numbers in this square up and divide it by 36, then we get 7. So our mean value is 7. I want to see if we can improve this value of 7 by having extra roles. But what if we were being particularly lucky and we could get a much higher number? And we can use a statistic called the 90th percentile, or the P90 as I'm going to call it, which tells us a value that 10% of the time we will get that value or higher. So we're looking at seeing if we can improve this P90 as well. So this is after banking after the first 2 roles, but what if we stayed in for an extra roll? Well, we've got 1 in 6 chance of wiping out, of getting that 6, and that's about 17%. So on that extra roll, we could wipe out, but we've also got an added number of possibilities. So our distribution goes from 3, because we could get 1, 1, 1, or we could get 6, 6, 5, so it could go up as high as 17. So we've got a much broader, wider possibilities. So we can calculate the mean from that, and the mean jumps up from 7 up to 8.3. And what about the P90? Well, that increases from 10 up to 13. So 10% of the time, we would get a score that is 13 or higher. Well, what about staying in for another roll? What if we stayed in for 2 rolls? Well, we've increased the chance of wiping out because we've had 2 chances of rolling a 6, but we've also increased the possibility of getting a higher score. So you can see our range of values is much higher. So what does that do to our mean? Well, our mean now goes from 8.3 to just over 9. So again, we've jumped up, not quite as much as we did before. And what about our P90? Well, that jumps up to 16. So on a lucky day, when we're in the top 10%, we could get as high as 16 with just 2 extra rolls. And we can keep doing this. We could keep working out the maths all the way up to, well, as far as we want to. And I'm going to plot these on this graph. So we've got our score going up on the y-axis, and on the x-axis, we've got the number of extra rolls. So we know the mean after no extra rolls is 7. And if we're being lucky in that top 10%, then we could get as high as 10. But we can also do that for the bottom 10%. So if I've called this being unlucky. And so that would give us a score of 4. And then we could do it for 1 extra roll. And we saw before how the P90 and the mean go up. But that unlucky value, the bottom 10%, that could go down to 0. Well, we know that 17% chance of wiping out, and 17 is higher than 10%. So that's why that's gone down to 0. And we can do that for 2 extra rolls. And again, we see that same pattern. But as we run it on up to 20, we can see that the mean goes up and then it starts to go down again. And we're looking for where that maximum value is. And if we've been lucky, we've also got a maximum value. So put a star around those values. And the best we can do for the mean is after 3 extra rolls. Now we've got a 42% chance of wiping out. That's just over 2 in 5 rounds we would wipe out, but we would still get a good mean of 9.3. So actually in that game, if you were, oh no, I've wiped out, actually you can expect to wipe out about twice and still be on the best strategy. If you're in the top 10%, you could get up to 37 points. But you've got almost a 1 in 10 chance of wiping out. 9 in 10 chance of wiping out. Only 1 in 10 rounds are you actually going to score that expected value of 37. And then if you're being particularly unlucky, then you'll wipe out after just 1 roll. So again, it depends on your how lucky you're being, which strategy works. But the mean is probably the best one to look at, the one we're expecting. So we're looking at 9.3. Now there is another strategy that we could try, and that is rather than going for an extra number of rolls, we could pick a score and see if that score is, once we reach that score, then we bank. And so what if we decided 10 was our target score? Well, once we reach 10, we then bank. And if we haven't reached 10, we can risk it. And we can do the same thing again. We can work out the maths. Our starting values this time start at 2, because we know that 2 is the minimum score we can get if we had 2 1s on the first 2 rolls. And then we can do that. We can run that on. I've run it up to stopping at 50. And again, we've got this pattern which goes up and then down again. So we're looking for that maximum value. And for the mean, that blue line, the score is 16. So once we reach 16, if you decide to bank then you would expect to score 9.4. And actually that's 0.1 higher than the previous strategy. So this strategy is actually better than staying in for 3 extra rolls. We've also increased the chance of wiping out from 42% to 45%. So again, you would expect to wipe out at least 2 in 5 times and still get that mean score of 9.4 if we pick 16 as our target value. If we're being particularly lucky in the top 10%, then we could get as high as 44. And if we're being unlucky, and then we might want to pick 7 as our target score. So what does that mean? I'm going to wrap this up with a bit of conclusion. And how does this apply to what we're doing? Well, what I do in my job. Well, risk can be estimated. You can put numbers on what the risk is, and that can help us make decisions. So thinking about the bolognese sauce and the washing powder and the toothpaste example, we can calculate what is the risk that harm will be caused either to the consumers or the factory workers or the environment. And then that can help us make a decision. But there's a couple of other things we need to consider as well. And that is what happens if there is a failure. So in the Dysec game, if we wipe out, then we score 0. That's maybe not such a bad thing. But what if one of our products does cause someone to have an allergic reaction? Well, that can be pretty bad for us as a company, because it will give us a bad reputation. And we want to be a company that is known for being safe and people can trust us. So a risk of a failure is much higher. So we have to make sure that when we've estimated this risk, that it leaves people with a very small chance of harm being caused. And we do make sure that our products are very safe. But we can't say that our products are 100% safe. We can just say that there is very low chance, like that chance of being harmed by the cyanide in an apple. So I'll leave you with these 2 pictures. The first picture on the left is they're both tightrope walking, but the one on the left, what if failure was to happen to that girl? What if she fell off that tightrope? Well, actually the risk isn't so bad, the risk is quite high, but the consequence of that risk is quite low. She'll probably just fall onto the ground and get back up and carry on. But for the guy on the right, then if a failure was to occur, then it could be catastrophic. So this is the other thing we need to think about when we're deciding what's going to happen. What happens if a failure happens? And which picture or where are we on this scale from the girl on the playground to the guy in the mountains? So thank you very much for listening. You can take the game idea and now you know the strategy to employ. You can play it with your family at home tonight. Maybe say that the loser has to do the washing up and you'll be in a good position to win that game. I can't guarantee it because there is still random chance in the game, but hopefully you are now in a place to assess risk and decide whether being greedy is good or bad. I think the answer to that question is you can make an informed decision just by employing a bit of maths and a bit of probability to that. So thank you. If there are any questions, I'll be happy to answer them.
Thank you, David. That was absolutely brilliant. I really enjoyed playing that game, and particularly because I did quite well on it. I've had a look at the scores. Chalk Hill School, well done. There's quite a few students in different classes, I think, from Chalk Hills. We've got 2 potential winners. Miss Stills has put in a score of 73. And then we've got the winner with Miss Patterson is a score of 76. So that was quite a high score.
And I imagine there was a lot of risk taking to get that score. So it can prove that taking risks can be very beneficial.
Absolutely. I think it's a balance, as everything. What I think is fascinating about that is how you use statistics in your job and how that sort of plays out in the real world, and some of those concepts, how it's used in a real world context. So thank you very much for that, David. If there's any questions, do put them in the chat. We are coming up to just 11 now. I would like to ask David, what does your work day look like? What's your sort of average day at work?
So things are slightly different now due to COVID. So I'll tell you what I'm doing now and what I would do if things were a bit more normal. So I turn up at work about 9 o'clock, and at the moment I'm working from home. And so I'm turning my computer on. I've set up a little desk in my house, and most of the time is spent on the computer looking at data. So some people would have done some experiments and given me the data to look at, or I'll be helping them to design an experiment, and then I'll be trying to make sense of that data. There's a lot of different, I mean, Unilever is great because it's such a great vast areas we look at. So it's environmental impact and health and things like that. So I do a lot of analysing the data using computer software, specialist computer software, that will do that. So that's most of my time, but the rest of it is usually in meetings, talking to people, trying to find out what they're trying to do with their so yeah, I work with a lot of scientists, chemists, biologists, immunologists, toxicologists, all these kind of clever people with PhDs that have done the, I'm trying to help them to with their data, make sense of their data. So I do a lot of talking to people, trying to find out what they want to do, explaining to them what they've done, that kind of thing.
Thank you.
Yeah, so I work from about 9 to about 5:30, and I have an hour off at lunch. So yeah, it's pretty straightforward.
To do your kind of job, what kind of GCSEs do you think are sort of important?
Well, so maths, and I actually did a GCSE in statistics, which I found those probably got me into it, doing it as a job. But I know you do some statistics as part of a GCSE maths. And then I think on its own, maths and doing statistics on it, studying that on its own isn't particularly useful, because you have to apply it to something. So I definitely wanted to do it in the area of science. So I did physics, biology and chemistry, all separate GCSEs. And that was really useful for me to work in the science industry. So so it could be, I mean, there's a lot of those subjects that are very useful for statistics. There was one job that I'd seen that was in Africa, looking at agriculture in Africa. And one of those things they required was to be able to speak French. And so to do your job, it's not just being good at maths, but it might be that you want to go and do it somewhere else. So languages or business studies is if you want to do it in work in a business side of things. So yeah, I would say, trying to answer it quickly, maths, and if you've got the option to do further maths like statistics, is definitely what you'd need to do, but also something else that you want to apply it to. So probably science from my point of view, but yeah, you have to kind of be interested in something else as well as maths. Yeah,
being an all-rounder is always a good thing. David, thank you so much. Really enjoyed today's session. I think, judging by all the reactions and the chat, I think everybody's really enjoyed it. So thank you so much for giving us a bit of an insight into how you apply statistics in your job. Thank you to Unilever as well, and for being the STEM ambassador for students. So thanks everyone. Have a good weekend and enjoy the rest of your day.
Okay, thank you.